All right, let's dive in. Today, we're going to crack the code on a topic that trips up so many people in algebra: absolute value inequalities. I know, they look super intimidating, but I promise by the end of this, you'll see they follow a really clear, logical pattern that's way easier to master than you think. Let's get to it.
So, picture this. You see something like this on a test. You've got these two vertical bars, an inequality sign, numbers all over the place. It's a lot to take in. Your first thought might be, where do I even start? It looks like it's designed to be confusing, but trust me, there's one simple idea that unlocks this entire puzzle.
And here it is. This is the key to everything. Before we even think about solving for x, we have to get our heads around what absolute value really is. So forget all the complicated rules for just a second and focus on one single word: distance. The core idea is actually pretty simple. The absolute value of a number is just how far away it is from 0 on the number line. That's it. And because distance can't be negative, you can't travel negative 5 feet, right? The absolute value is always going to be a positive number or 0.
Just think about it like this. If you're at 0 and you walk 5 steps to the left, you're at -5. If you walk 5 steps to the right, you're at +5. In both cases, how far did you walk? 5 steps. The distance is exactly the same. The direction just doesn't matter for absolute value.
And this is where the whole concept gets really powerful. We can take it beyond just the distance from 0. When you see an expression like the absolute value of x minus c, it's really just asking a simple question. What's the distance between the point x and the point c? Keep that idea, it's just distance, in your head because it is about to make everything else just click into place.
Okay, so once we get that it's all about distance, we find out that every single one of these problems sends us down one of two possible paths. It's like a fork in the road. And the signpost that tells you which way to go? It's the inequality sign itself. Is it a less than problem or a greater than problem?
And this slide right here is the money shot. This is the crucial difference. If you've got a less than sign, you're dealing with an and statement. Your answer is going to be trapped between two numbers. We call it a sandwich. But if you have a greater than sign, it's an or statement. The solutions are flying away from the middle in opposite directions. So remember, less than is a sandwich, greater than is or. They're heading outwards.
So now that we have the why, it's all about distance and these two paths, let's get to the how. And the great news is there's a simple, repeatable, 3-step mission that is going to work for you every single time.
That's it. This is your entire game plan. First, you got to get that absolute value expression all by itself on one side of the inequality. Second, you split the problem into its two cases. Is it the and sandwich or the or statement? And finally, you just solve the new inequalities you've made. Let's see this whole mission in action.
Okay, here's our first target. See that less than sign? That's our big clue. It's screaming at us that we're dealing with an and problem. We're about to make a sandwich. Let's deploy those 3 steps.
Let's walk through it. Step 1, we add 6 to both sides to get that absolute value part all alone. Super easy. Now for step 2, because it's less than, we build our sandwich. The stuff on the inside, x plus 4, gets trapped between -15 and +15. And for step 3, we just subtract 4 from all 3 parts to get x by itself. And boom, there's our solution. X is any number between -19 and 11.
All right, time to take that other path. Check out that greater than or equal to sign. That's our signal that we're on an or mission. The solutions are going to be heading in opposite directions. We use the same 3 steps, we're just on a different path.
Okay, step 1, you know the drill. Isolate, add 7 to both sides, and we get the absolute value of 2x minus 1 is greater than or equal to 4. Now step 2, split. Because it's greater than, we create 2 completely separate or inequalities. Then, for step 3, we just solve each of those on its own. And look at the result. It's totally different. Instead of one cozy range, we get 2 separate answers that go off in opposite directions.
So you've totally mastered the 2 main paths. But, you know, math always has a few curveballs, right? There are 2 really common traps you need to watch out for. These are the special cases where you can actually find the answer without doing all the work.
Let's rewind all the way back to that very first problem we looked at. Remember this beast? Well, if we follow our step 1 and just isolate the absolute value, we subtract 4 from both sides, we get this. The absolute value of 5x plus 6 is less than -3. Now, wait a minute.
This is where you have to pause and just think about what absolute value means. Remember, it's distance, and distance is always positive or 0. So rule 1, can a distance be less than a negative number? No way, that's literally impossible. Rule 2, Can a distance be greater than a negative number? Well, yeah, of course it can. It always is.
And just like that, the mystery is solved. The answer to that first tricky puzzle is no solution. We didn't even have to get to step 2. The second you isolate the absolute value and see that it's supposed to be less than a negative number, you can stop. Game over. The problem is asking you to do something impossible.
Okay, so why does any of this actually matter outside of your math class? It can feel a little abstract, I get it, but this whole idea of distance from a central point is actually incredibly practical.
Seriously, think about it. When a company makes, say, a piston for an engine, it has to be a certain size, plus or minus a tiny fraction of an inch. That's an acceptable range. When you go shopping with a budget, you have a target price with a little bit of wiggle room. Absolute value inequalities are the perfect mathematical tool for describing these kinds of acceptable ranges.
And that really gets to the heart of what we're doing here. It's one thing to just memorize a bunch of steps to solve a problem. It's something else entirely to actually understand why those steps work. The moment you really grasp that absolute value is just about distance, the whole and or thing suddenly makes perfect sense. You're not just following a recipe anymore. You actually get the logic behind it.
So I'll leave you with a little brain teaser. The next time you see a news report on a poll that says something like 45% of people approve with a margin of error of plus or minus 3%, stop and think. How would you write that as an absolute value inequality? You now have the tools to translate that real-world idea into the language of math. Thanks for tuning in.